Imagine looking up at the night sky and seeing a galaxy, a vast island of stars containing hundreds of billions of suns. It already feels unimaginably large. Light itself needs 100,000 years to cross our Milky Way from one side to the other. That alone is difficult for the human mind to understand. But tonight, we are going much farther, beyond the stars, beyond the spiral arms, beyond our own galaxy. Because the most terrifying distances in the universe are not found between planets, not between galaxies. Entire cosmic islands separated by oceans of darkness, so vast that even light can spend millions of years crossing them. And suddenly, our galaxy begins to feel small. Tonight, on What If Beyond, we will explore the true distance between galaxies. Why the universe is far larger than most people imagine, and what would really happen if humanity ever tried to cross the enormous void between these distant worlds of stars. But before we continue, tell me something in the comments. What time is it where you are right now? And from which city are you listening? I always enjoy seeing where these journeys through the universe are being heard from. And if you enjoy calm space documentaries like these, consider subscribing to What If Beyond. Now, get comfortable, relax, and let's travel beyond the Milky Way into the greatest distances the universe has to offer. The first thing to understand about galaxies is that they are already almost impossible to imagine. A galaxy is not just a bright cloud in space. It is not just a spiral shape in a telescope image. It is an island of stars, a vast gravitational system containing billions, sometimes hundreds of billions, sometimes even trillions of stars. Each one of those stars may have planets. Some may have moons, some may have asteroid belts, comets, storms, oceans, frozen worlds, dead worlds, newborn worlds, and strange places no human has ever seen. And all of that can exist inside one galaxy. Our galaxy, the Milky Way, is so large that light itself needs around 100,000 years to cross it from one side to the other. That means if a beam of light began traveling from one edge of the Milky Way when early humans were still living in a completely different world, it might only now be reaching the opposite side. And light is the fastest thing in the universe. Nothing with mass can move faster through space. So, when we speak about crossing a galaxy, we are not speaking about a difficult journey. We are speaking about a distance so large that time itself becomes part of the landscape. But here is the terrifying part. A galaxy is not the largest distance problem in the universe. It is only the beginning, because galaxies are not touching each other. They are not neatly placed side by side like cities on a map. They are separated by darkness, immense oceans of space where almost nothing shines. The distance between stars is already enormous, but the distance between galaxies is worse, much worse. And this is where the universe begins to break the human sense of scale. From Earth, when we look at images of galaxies, they often seem close together. A photograph may show dozens of galaxies in one frame. Some appear large, some small, some elliptical, some glowing faintly in the background. And because they are all inside the same image, our brains begin to feel that they are near each other. But they are not. That image is lying to your intuition. Not because the image is fake, but because the depth is missing. Two galaxies can appear close together in the sky, while actually being separated by millions or even billions of light years. They may only look near because they happen to line up from our point of view. The universe is not flat like a picture. It has depth, and that depth is almost impossible to feel through a screen. This is why galaxy distance is so unsettling. We can see galaxies, we can name them, we can photograph them, we can measure their light, but seeing something does not make it reachable. A galaxy can be visible to a telescope and still be so far away that its light began traveling before humans existed, before Earth looked the way it does now, before entire forms of life appeared and disappeared. When you look at a galaxy, you are not simply looking across space. You are looking across time. The farther away a galaxy is, the older the light reaching us. Some galaxies appear to us as they were millions of years ago. Others, billions. The deep universe is not showing us what everything looks like right now. It is showing us a layered archive of ancient light, a cosmic memory arriving late. And between those galaxies, there is darkness. Not darkness like night on Earth, not darkness filled with air, clouds, weather, and sound. A deeper darkness, an intergalactic darkness. A space so empty that even calling it empty feels too small. Inside a galaxy, stars are separated by vast distances. But at least there are many stars. There are clouds of gas, dust, star clusters, nebulae, planets, black holes, remnants of dead stars. There is structure. There is activity. There are places. But between galaxies, the universe becomes thinner. The stars become rare. Matter becomes diffuse. The bright landmarks disappear. A spacecraft, leaving the Milky Way, would eventually pass beyond the dense star fields, beyond the familiar spiral structure, beyond the glowing disk of our galaxy. And then it would enter the void between galaxies. There would be no nearby stars like the Sun, no planets waiting, no moons, no solar systems to pass through every few years. Only the Milky Way shrinking behind, and another galaxy far ahead. If the destination were Andromeda, our nearest large galactic neighbor, the ship would be facing a journey of about 2.5 million light years. 2.5 million. That number sounds almost unreal. Light itself takes around 2.5 million years to travel from Andromeda to Earth. So when you look at Andromeda in the night sky, you are not seeing it as it is today. You are seeing it as it was before modern humans built civilization, before cities, before writing, before agriculture, before almost everything we think of as human history. The light entering your eyes began its journey when Earth was a different world, and that is the closest large galaxy. Not a distant one, not one at the edge of the observable universe. The closest major galaxy to us, already millions of light years away. This is the first true shock of galactic distance. The Milky Way is enormous, but the space beyond it makes even the Milky Way feel like an island in a dark ocean. Imagine the Milky Way as a glowing city at night, a city with hundreds of billions of lights. Now imagine another city far away across a black sea. From a mountain, maybe you can see its glow. Maybe you can identify its shape. Maybe you can prove it exists. But between you and that city, there is an ocean so wide that no ship you have can cross it. That is what galaxies are like. Visible, real, beautiful, but separated by distances that make human travel feel almost meaningless. And even this comparison is too small, because oceans on Earth are still part of one planet. They have winds, water, currents, storms, life. A ship can float, a sailor can look at waves and feel movement. But intergalactic space has no surface, no air, no coast, no sound, no natural support. A spacecraft traveling between galaxies would not be sailing. It would be drifting through nearly empty space, surrounded by darkness so complete that the original galaxy behind it might become the only emotional reference point left. At first, the Milky Way would still fill the sky behind the travelers, a huge, glowing spiral, a majestic structure of stars, dust, and light. From outside, our galaxy might look more beautiful than humans ever saw it. From within, the bright center glowing, the spiral arms curling outward, dark dust lanes cutting across starlight, the sun hidden somewhere inside one small region of one spiral arm, Earth invisible, humanity invisible. Everything we have ever loved, built, feared, and imagined, reduced to one microscopic point inside a vast galaxy. Then, as the ship traveled farther, even that galaxy would shrink. The Milky Way would no longer surround the travelers. It would become an object, then a disk, then a bright patch, then a distant glow behind them. And ahead, Andromeda would grow almost unbelievably slowly. For thousands of years, it might barely seem larger. For millions of years, depending on the speed, it would remain a distant island. This is what galactic distance does. It turns travel into something almost beyond story. A journey from Earth to Mars can be imagined as a mission. A journey to Proxima Centauri can be imagined as a civilization-defining expedition. But a journey between galaxies, that becomes something else. Not a mission, not an expedition, a migration across deep time. A movement so long that the travelers who leave could never be the ones who arrive, unless they possess technologies far beyond anything humanity currently understands. A ship traveling between galaxies would need to solve every problem of interstellar travel, and then multiply it by something much greater: energy, radiation, dust, navigation, life support, psychology, maintenance, memory, society, purpose. All of it would have to survive across distances that make even the nearest star seem close. This is why galaxy distance is so terrifying. Not because galaxies are dark. They are bright. Not because they are unknown. We know many things about them, but because they reveal how trapped we are by scale. We live inside one galaxy, and that galaxy alone is already larger than any human civilization could fully cross with today's technology. But beyond it are other galaxies, not one, not a few, trillions may exist across the observable universe, each one a universe-like island of stars. Each one separated by distances that make ordinary language feel weak, and the deeper we look, the more galaxies appear. The famous deep field images changed how humans understand darkness. A telescope looked at a tiny patch of sky that seemed almost empty, a small black region, nothing special, and with enough exposure, that darkness filled with galaxies, not stars, galaxies, thousands of them, in a patch of sky so small it could be covered by something tiny held at arm's length. That means the darkness above us is not empty. It is crowded with galaxies so distant and faint that our eyes cannot see them. Every black patch of night may be hiding cosmic islands, not because they are few, but because they are far. This is one of the strangest truths in astronomy. The universe can be full and still look empty, because distance hides abundance. A galaxy with hundreds of billions of stars can become a faint smudge. A cluster of galaxies can become a tiny group of dots. A structure larger than anything humans can experience can disappear into darkness simply because it is far enough away. And so, when we look at the night sky, we do not see the universe as it is. We see only what distance allows us to see. The nearest lights, the brightest stars, a few planets, some faint objects. But behind that visible sky is a depth filled with galaxies, layer after layer, farther and farther, older and older. A universe so large that even the light crossing it becomes ancient. Now think again about the distance between the Milky Way and Andromeda, about 2.5 million light years. Andromeda is approaching us over cosmic time. One day, billions of years from now, the Milky Way and Andromeda will merge into a new, larger galaxy. That sounds dramatic, but the collision will not happen like two solid objects smashing together. Galaxies are mostly empty space. Even when galaxies merge, most stars do not collide directly. They pass through the enormous gaps between one another. Gravity reshapes everything. Stars are pulled into new orbits. Gas clouds may compress and form new stars. The galaxies distort, stretch, and eventually settle into a new structure. It is violent on a galactic scale, but strangely spacious on a stellar scale. This tells us something important. Even galaxies themselves are mostly empty. A galaxy can contain hundreds of billions of stars and still have so much empty space inside it that two galaxies can merge without most stars touching. So if galaxies are already mostly empty, then the space between galaxies is emptiness on another level, a deeper level, a scale where even the bright islands become separated by cosmic deserts. And yet, gravity still connects them. The Milky Way and Andromeda are part of the local group, a collection of galaxies bound together by gravity. There are smaller galaxies too, dwarf galaxies, satellite galaxies, companions orbiting larger systems. The local group itself is part of a larger cosmic neighborhood, and that neighborhood connects to even greater structures, galaxy groups, galaxy clusters, superclusters, filaments, voids, The universe is not randomly sprinkled with galaxies. On the largest scales, galaxies form a cosmic web, vast filaments of matter stretching across the universe, with galaxies clustered along them like lights on invisible threads. Between those filaments are voids, huge regions with far fewer galaxies, cosmic empty spaces so large that entire galaxy clusters seem like small knots along the edges. If you could zoom out far enough, the universe would not look like isolated galaxies floating randomly. It would look like a web, a network, a structure of light and darkness. But from inside one galaxy, we cannot feel that structure. We only see fragments of it. A galaxy here, a cluster there, a faint glow far away. The true architecture of the universe appears only when we step far back, mentally. And when we do, the scale becomes almost unbearable. The distance between planets is large. The distance between stars is enormous. But the distance between galaxies belongs to the cosmic web, to the structure of the universe itself. It is not just travel distance. It is the spacing of reality on its largest visible scales. This is why the topic matters. The distance between galaxies is not only a number, it tells us where we are. It tells us how small our galaxy is compared to the larger universe. It tells us how limited our travel may be. It tells us that the universe is full of islands we may observe but never reach. And it tells us that light is both a gift and a limit. Light allows us to see Andromeda, but it also reminds us that Andromeda is millions of years away in time. Light brings us the image, but not the place. Seeing is not arriving. Knowing is not crossing. And perhaps that is one of the deepest lessons of astronomy. The universe can reveal itself without becoming reachable. It can show us galaxies, clusters, and ancient light, while keeping the distances between them almost impossible to overcome. The Milky Way is our home galaxy. Andromeda is our nearest great neighbor. But between them lies a darkness so vast that human history would be swallowed by the crossing. And beyond Andromeda are more galaxies, farther groups, farther clusters, farther structures, each distance larger, each light older, each step outward pushing us deeper into a universe where human lifetimes become almost nothing. This is where part 1 begins, with the realization that galaxies are not just beautiful objects in space. They are separated worlds of stars, cosmic continents, divided by oceans of darkness. And the nearest great one is already so far away that its light began traveling before civilization existed. So, when we ask how far apart galaxies really are, we are not asking a simple astronomy question. We are asking how large the universe feels when the spaces between its greatest structures are finally taken seriously. And the answer is humbling, because the galaxies we see are not close. They are not waiting nearby. They are not cities across a small sea. They are ancient islands of light, drifting across distances so vast that even the closest one reminds us how impossible the universe truly is. To understand the distance between galaxies, we have to stop imagining galaxies as bright objects floating close together in a dark room. That image is too small, too comfortable, too human. A galaxy is not simply an object in space. It is a territory, a gravitational kingdom, a system with a center, a disk, spiral arms, star clusters, gas clouds, dark matter, satellite galaxies, ancient stars, wandering objects, and a vast invisible halo stretching far beyond the bright part we usually see. When we look at a picture of the Milky Way, we usually imagine the glowing disk, the spiral arms, the bright central bulge, the familiar shape of a galaxy seen from outside. But the visible galaxy is only part of the story. Around it is a much larger halo, a faint region of old stars, globular clusters, dark matter, and diffuse gas. This halo does not shine like the disk. It does not appear dramatic in most images, but it extends far beyond the beautiful spiral shape we normally imagine. And that means even leaving a galaxy is not simple. A spacecraft traveling away from the Milky Way would not pass a clear border and suddenly enter outside. There would be no wall, no edge, no line in the darkness saying the galaxy ends here. Instead, the galaxy would fade, slowly. The crowded star fields would thin out. The spiral structure would fall behind. The bright disk would shrink. The halo would become more diffuse. The sun would become one star among countless others behind the ship. And still, the spacecraft would remain under the influence of the Milky Way for a long time, because gravity does not end sharply. A galaxy's reach fades gradually into the emptiness around it. This is one reason galactic distance is hard to understand. The objects themselves are not neat balls separated by clean gaps. They have invisible outskirts, halos, gravitational relationships, satellite systems, streams of stars torn from smaller galaxies, gas moving through intergalactic space, dark matter extending farther than the visible light. A galaxy is more like a city surrounded by suburbs, roads, abandoned ruins, and invisible borders of influence. And when galaxies interact, those borders can overlap long before the bright parts touch. The Milky Way itself is not alone. It has companions. Small satellite galaxies orbit around it. The Large Magellanic Cloud, the Small Magellanic Cloud, dwarf galaxies, some faint and difficult to detect, moving through the Milky Way's gravitational environment. These smaller galaxies remind us that the space around a galaxy is not completely empty. There are structures nearby, fragments, companions, ghostly systems with far fewer stars than the Milky Way. Some are being stretched, disrupted, and slowly absorbed. The Milky Way is not frozen in place. It is still growing, still interacting, still shaping and being shaped by its surroundings. But even these companion galaxies do not make the universe feel crowded. They only reveal another layer. A galaxy has neighborhoods, groups, families. The Milky Way and Andromeda are part of the local group, a collection of galaxies bound together by gravity. Some are large, most are small. The local group is not like a dense city. It is more like scattered islands within a dark sea, held together by invisible gravity. And beyond the local group, the distances grow again. This is where the mind begins to struggle. Because if Andromeda is already 2.5 million light-years away, then the next larger structures are even farther. Galaxy groups gather into clusters. Clusters gather into larger arrangements, and the universe begins to appear as a network of bright regions, separated by vast voids. If the Milky Way is a city of stars, then the local group is a small cluster of cities. But galaxy clusters are like entire nations of galaxies. Hundreds or thousands of galaxies can be bound together inside a cluster. The Virgo cluster, for example, is far beyond our local group. It contains many galaxies and represents a much larger gravitational structure in our cosmic region. But reaching a cluster like that is not simply a bigger trip. It is a leap into a scale where the distances between groups become almost unimaginable. The local group itself is already enormous, but compared to larger cosmic structures, it becomes just one small piece. This is the pattern of the universe. Every scale that feels large becomes small when the next scale appears. Earth feels large until we compare it to the solar system. The solar system feels large until we compare it to nearby stars. The distance to Proxima Centauri feels enormous until we compare it to the distance to Andromeda. The Milky Way feels vast until we compare it to galaxy clusters. And even galaxy clusters become small knots inside the cosmic web. The universe keeps expanding the frame. Every time the human mind finds a boundary, space moves the boundary farther away. But the most important thing about the distance between galaxies is not only how large it is what exists inside that distance. The space between galaxies is called intergalactic space, and it is one of the emptiest environments in the universe. Inside a galaxy, there are stars, planets, nebulae, black holes, and clouds of gas. There is still enormous emptiness between objects, but at least the galaxy has structure. It has light. It has regions. It has landmarks. Intergalactic space is different. It is not perfectly empty. Nothing in the universe is truly simple. There is thin gas. There are particles. There may be stray stars ejected from galaxies. There may be dark matter. There may be faint radiation and magnetic fields. But compared to a galaxy, it is almost unimaginably sparse. If a traveler somehow left the Milky Way and headed toward Andromeda, most of the journey would not be spent passing interesting objects. It would be spent crossing nothing. Not nothing in a poetic way. Nothing in a practical way. No planets. No nearby stars. No glowing nebulae. No safe harbors. No familiar cosmic scenery. Only a ship moving through a darkness so vast that even the Milky Way behind it and Andromeda ahead of it would remain distant for most of the crossing. This is why intergalactic travel is so different from interstellar travel. Between stars, at least the destination is another star system. There may be planets, there may be light, there may be gravitational landmarks, but between galaxies, the journey is longer and emptier. The traveler is not moving from one nearby fire to another. They are moving between entire continents of stars, and the sea between them is almost blank. This blankness creates a strange kind of terror. Not the terror of violence, not explosions, not storms, but the terror of absence. A journey where the most dangerous thing is the lack of anything. No help, no resources, no landmarks, no reason to believe the universe is aware of your passage at all. A spacecraft could travel for ages through intergalactic space and still appear motionless from the human point of view. The stars of the Milky Way would slowly compress behind it. The destination galaxy would grow slowly ahead, but for most of the journey, nothing nearby would change. Time would pass, the ship would continue, and outside, the same blackness would remain. This is where distance becomes psychological. Humans can endure danger when danger has a face. A storm, a mountain, a fire, a predator, a broken machine. But how does a mind endure a distance so empty that nothing happens for longer than civilizations have existed? How does a traveler understand progress when the destination barely changes? How does a society keep meaning alive inside a ship, crossing a void that has no seasons, no sky, no natural rhythm? These questions matter because crossing between galaxies would not be a mission for astronauts alone. It would require something larger. A machine can be sent across emptiness. A probe could drift for millions of years if it survived long enough. But humans cannot think in millions of years as a normal journey. Human life is short. Human societies are unstable across long time. Languages change. Cultures change. Beliefs change. Technology changes. Even memory changes. A journey to another galaxy would require continuity beyond anything humanity has ever maintained. A generation ship traveling between stars is already difficult to imagine. A generation ship traveling between galaxies becomes almost mythological. The people who arrive would not simply be descendants of the people who left. They might be a completely different civilization. Their ancestors' reasons for launching may no longer feel important. Earth may be legend. The Milky Way may be myth. The destination may become religion, duty, burden, or mystery. At that point, travel becomes something else. It becomes inheritance, a world inside a ship, carrying a mission that no individual chose. And this raises a deep question. Would a civilization even want to cross between galaxies? Not dream about it, not imagine it, but truly commit to it. To send life across millions of light years with no guarantee of arrival, no promise of meaning, and no living memory of departure. Maybe the answer is yes in some far future. Maybe a species that becomes old enough begins to think on scales beyond individuals. Maybe it builds machines that preserve life, memory, or intelligence across cosmic time. Maybe it sends seeds of civilization into darkness. But for humans, as we are now, the distance between galaxies is not a road. It is a reminder that some parts of the universe may be visible, but effectively unreachable. And then there is another problem. The universe is expanding. This changes the meaning of galactic distance completely. Galaxies are not simply sitting in space while we decide whether to travel between them. On large scales, space itself is stretching. Distant galaxies are moving away as the universe expands. The farther away they are, the faster they appear to recede from us. This does not affect nearby gravitationally bound systems in the same way. The Milky Way and Andromeda, for example, are moving toward each other because gravity dominates locally. The local group is bound together. But beyond local structures, expansion becomes more important. And at great distances, expansion creates a terrifying consequence. Some galaxies are not just far, they are becoming unreachable forever. Their light may reach us now because it was emitted long ago when they were closer. But as space expands, there are regions of the universe whose future light will never reach us. Galaxies that future civilizations may never see. Cosmic islands slipping beyond the observable horizon. This means the universe is not only large, it is changing in a way that closes doors. The longer time passes, the more isolated, distant regions become. Galaxies beyond our local gravitational neighborhood will drift farther away in the cosmic expansion. In the far future, if intelligent beings still exist in the Milky Way or whatever galaxy forms after the Milky Way and Andromeda merge, the distant universe may appear much emptier. Many galaxies visible to us today will have moved beyond detection. The cosmic web will fade from view. The universe will not become smaller, but it will become less visible. That idea is haunting. We live in an era where the universe is still open to observation. We can see galaxies across vast distances. We can study ancient light. We can map large-scale structure. But this window may not last forever. Future astronomers may inherit a darker sky, a sky where the evidence of distant galaxies is gone. They may look outward and see only their own merged galactic system, surrounded by darkness. They may not know, without ancient records, that the universe once appeared full of galaxies. This is one of the strange gifts of our time. We exist early enough to see the larger universe, not at the beginning, not near the first stars, but early enough that galaxies beyond our local region still send light to us, early enough that the universe has not yet hidden most of itself behind expansion. And this makes the distance between galaxies even more meaningful, because the light we receive is not guaranteed forever. Every galaxy we see is part of a temporary cosmic visibility, a message from a region that may one day be unreachable in every practical sense. We are not only looking across space, we are looking while the door is still open. But observation is very different from travel. Light can reach us from galaxies we can never visit. That is one of the deepest separations in astronomy. The universe allows knowledge to travel farther than life. Photons can cross millions and billions of light years. Signals can reveal galaxies that no spacecraft will ever reach. But matter, ships, bodies, and civilizations are trapped by energy, time, and expansion. This means astronomy may always go farther than exploration. Our eyes, through telescopes, may travel to the edge of the observable universe. Our machines may someday reach nearby stars, but our bodies may never cross even one major intergalactic gap. And if that is true, then the distance between galaxies creates a kind of cosmic humility. It tells us that seeing is not the same as possessing. Measuring is not the same as reaching. Understanding is not the same as crossing. A galaxy can be known in detail and still remain forever beyond human footsteps. This is hard for us because human history often connects knowledge with access. When we mapped continents, people traveled there. When we studied oceans, ships crossed them. When we saw the moon, humans eventually landed. So we naturally imagine that if we can study galaxies, maybe one day we can go. But galaxies may be different. The distances may be so enormous that travel becomes less like exploration and more like a cosmic fantasy, not because physics forbids every possible path absolutely, but because the requirements are so extreme that they exceed anything human civilization can currently imagine sustaining. Even near light-speed travel would not solve everything. At high speed, time dilation could make a journey shorter for the travelers, but to cross millions of light years, the energy requirements would be beyond anything we know how to control. And from the point of view of the universe left behind, immense time would pass. A crew might experience less time if traveling close enough to light speed, but the galaxy they left would age enormously. The civilization that launched them might be gone. The destination galaxy might change. The universe itself would continue evolving. Time dilation is not a magic bridge. It is a trade. It lets travelers survive time differently, but it separates them from their origin even more deeply. A mission to Andromeda at extreme relativistic speed would not simply be a trip across distance. It would be a departure from history. The travelers might arrive while the Milky Way has changed beyond recognition. They might never return to the world, culture, or era that sent them. They would become not just explorers, but time exiles. And if the journey involved many millions of light years to farther galaxies, the separation becomes almost absolute. The universe they arrive in may no longer resemble the universe they left. This is why galactic travel feels so strange. It does not only challenge space, it challenges identity. Who are you if the civilization that launched you is gone? What is a mission if the people who planned it vanished long before arrival? What does destination mean if the journey outlives memory? For humans, meaning depends on continuity. We want the story to connect: departure, journey, arrival, return. But the distance between galaxies breaks that structure. There may be departure, there may be journey, there may even be arrival. But return, in any emotional sense, may be impossible. Even communication across galactic distances becomes difficult in a way that feels almost absurd. If humans reached Andromeda and sent a message back to the Milky Way, that message would take about 2.5 million years to arrive. A simple greeting would travel longer than human civilization has existed. A reply would take another 2.5 million years. One question and one answer across 5 million years. That is not communication as humans understand it. That is archaeology by radio. A conversation between civilizations separated by geological time. By the time a message is received, the sender's world may be unrecognizable. By the time the reply returns, the original question may belong to myth. This means, even if galaxies are visible to each other, they may be socially isolated. A civilization in one galaxy could detect another, maybe even send signals, but meaningful conversation becomes almost impossible across millions of light years. The universe may be full of intelligence, and still most of it may be too far away to talk to in any living sense. That is one of the loneliest possibilities. Not that life is absent, but that distance prevents connection. There could be civilizations in other galaxies, ancient minds, complex histories, art, science, dreams, fears, questions. But if they are millions of light years away, their light is old, their signals are old, their present is inaccessible. We may see evidence that they existed, but not share the same moment with them. This turns the universe into a museum of delayed realities. Every distant galaxy is seen as it was, not as it is. Every signal from far away is a fossil of activity. Every image is a historical document. The farther we look, the less we see the present. And so, the distance between galaxies does something strange. It fills the universe with ghosts. Not supernatural ghosts, light ghosts, time ghosts, galaxies as they were, events long finished, stars that may have died, civilizations, if they existed, that may have changed beyond recognition. We look outward and see an ancient universe layered across the sky. The night is not simply dark, it is old, and between those old lights are gaps no human life can cross. This is why the distance between galaxies feels worse than we think. Because it is not only a number of light years, it is a separation of present moments. When we look at Andromeda, we see the past. When Andromeda hypothetically sees us, it would see Earth's past too. No galaxy sees another galaxy as it is now. The universe is stitched together by delayed light. Every observer lives inside their own present, surrounded by images of other places from other times. There is no single cosmic now that everyone can simply share by looking. Distance breaks simultaneity in the human sense. And when the distances become galactic, the break becomes enormous. This makes the universe feel less like one connected place and more like countless regions sending old stories through darkness. Some stories arrive, some never will. Some are already beyond reach, some are fading. Some are still traveling, and we, on Earth, receive them with telescopes and call it observation. But behind every image is a distance that cannot be crossed easily. This is the deeper truth of galactic distance. Galaxies are not only far apart in space, they are far apart in time, far apart in communication, far apart in possibility, and sometimes far apart in destiny. The Milky Way and Andromeda are bound together. They will meet one day, but many other galaxies are moving away into a future where they will become unreachable. The universe is not a static map. It is a changing ocean. Some islands drift closer. Most drift away. And the scale of that movement is beyond human control. So, if part 1 showed that galaxies are islands separated by vast darkness, part 2 reveals something even more unsettling. Those islands are not waiting. They are moving. Their light is old. Their distances are growing on the largest scales. Their present is hidden, and the space between them is not just empty. It is a barrier made of time, expansion, silence, and the limits of life. To look at galaxies is to witness beauty. To understand their distance is to feel trapped. not trapped on Earth only, not even trapped in the solar system, but trapped inside one cosmic island, looking out at others across an ocean that may never be crossed. And perhaps that is why galaxies are so powerful to us. They are both proof of abundance and proof of separation. The universe contains more worlds than we can imagine, more stars, more systems, more possibilities, but it places them across distances so vast that most may remain forever out of reach. The sky is full of light, but between the lights, there is a silence large enough to swallow civilizations. And that silence is the true distance between galaxies. There is a place in the universe where the word distance almost stops meaning anything, not because distance disappears, but because it becomes so large, so empty, so disconnected from ordinary experience, that the human mind begins to lose its grip. These places are called cosmic voids, and they may be the closest thing the universe has to true emptiness. Not perfect emptiness, not absolute nothing, but enormous regions where galaxies are rare, where the bright islands of stars become scattered so far apart that the universe itself begins to feel abandoned. If galaxies are cosmic cities, then voids are the dark wilderness between civilizations, vast regions where the usual landmarks fade away, where the glowing web of matter thins into silence, where a traveler could move across distances so enormous that entire galaxies would become lonely points on the edge of vision. And this is where the distance between galaxies becomes even worse than most people imagine, because galaxies are not spread evenly through the universe. They do not fill space like grains of sand in a box. They gather, they cluster, they form groups, chains, walls, and filaments. And between those structures, there are voids, huge dark spaces with far fewer galaxies than average. When astronomers map the large-scale universe, it does not look like a smooth field of lights. It looks like a web, a vast cosmic network. Galaxies collect along glowing filaments, like drops of dew on invisible threads. Clusters appear where filaments meet, bright knots in the structure of the universe. And between them are enormous empty regions, dark bubbles, cosmic deserts, voids so large that our entire galaxy would feel tiny inside them. This cosmic web is one of the most important structures in the universe. It was shaped by gravity over billions of years. Tiny differences in density in the early universe grew slowly. Regions with slightly more matter pulled in more matter. Regions with slightly less matter became emptier. Over time, galaxies formed along the denser strands. The emptier regions expanded into voids, so the universe became patterned. Not random, not smooth, but structured. Light gathered into filaments. Darkness opened between them. And Earth exists inside this structure without feeling it. We live in a galaxy. That galaxy belongs to a group. That group belongs to a larger cosmic environment. And all of it is part of a vast web whose full scale no human can see with their eyes. We are inside the pattern, trying to map the pattern, like an insect standing on a single thread of a spider web, trying to imagine the entire design. This is what makes galactic distance so unsettling. It is not only that galaxies are far apart, It is that the universe has architecture on scales far beyond human experience. There are roads of galaxies, and there are emptinesses between the roads. There are bright regions, and there are dark regions. There are places where galaxies crowd together, and places where almost nothing shines for hundreds of millions of light years. Imagine being inside one of those voids. Not near the edge, not close to a cluster, but deep inside. Your home galaxy would be isolated in a way the Milky Way is not. The sky might look far emptier. The nearest large galaxies might be incredibly distant. The night might contain fewer bright neighboring structures. And for any civilization living there, the universe could feel very different. They might not see the same crowded cosmic web that we detect. They might look out and find themselves surrounded by darkness. Their astronomy might begin with loneliness. If they existed early enough, and if their instruments were not powerful, they might believe the universe was mostly empty, not because they were foolish, but because location changes what the universe reveals. Where you live in the cosmic web affects what you can easily see. A civilization inside a dense cluster would see galaxies everywhere. A civilization inside a void would see a quieter sky. Both would live in the same universe, but the universe would feel different to each. This is a strange thought. The cosmos does not look the same from every place. Not emotionally, not observationally, not historically. Your position inside the cosmic web shapes your first idea of reality. Humanity was born inside the Milky Way, in a region where the sky is rich enough to inspire astronomy, but not so crowded that galaxies dominate the night. We see stars. We see the Milky Way. With tools, we see galaxies. But imagine if Earth had formed in a galaxy deep inside a massive void. The nearest galaxies might be so far away that early astronomers would struggle to detect them. Their night sky could teach a different lesson. Not abundance, isolation. And maybe their first great cosmic question would not be, why are there so many galaxies? But is there anything beyond us at all? That is how powerful distance can be. It does not only separate objects, it shapes knowledge. It shapes imagination. It shapes what a civilization believes is possible. And this leads to another unsettling idea. The universe we observe is not only the universe as it is the universe as seen from our position. Our maps are extraordinary. Our telescopes are powerful. But we are still making every observation from one small location inside one galaxy. We look outward from here, not from the center of the universe, because there is no special center in the ordinary sense, not from a privileged viewpoint, just from our place, a small world inside a spiral galaxy, inside a local group, inside a larger cosmic flow. From here, we reconstruct the universe. We measure redshifts. We map galaxy distributions. We estimate distances. We build models of the cosmic web. But every map of the universe is still a map made from inside the universe, and that makes it humbling. We are trying to understand something larger than any possible outside view. No human can step outside the cosmos and look at it whole. We must infer the whole from inside the part. This is why galactic distance is more than a travel problem. It is a knowledge problem. The farther away something is, the more difficult it becomes to understand clearly. Its light is faint. Its image is old. Its details are blurred by distance. Its motion must be interpreted. Its present is hidden. So every distant galaxy is not only far away, it is partly unknowable in the direct sense. We can study it. We can learn from it, but we cannot interact with it as it is now. We cannot see its current state. We cannot receive its present. We cannot know what changed there after the light began traveling. A galaxy may look young in our telescope because its light is ancient, but somewhere in its own region of time, it may have evolved. Stars may have died. New ones may have formed. Black holes may have grown. Galaxies may have merged. Civilizations, if any ever existed there, may have risen and vanished. But to us, it remains a preserved image from the past, a cosmic message that arrived late. This creates a universe filled with unreachable presence. Everything far away has a now that we cannot access. That may be one of the most difficult truths to accept. The universe is not only separated by space, it is separated by time. And the greater the distance, the more the present disappears. When we look across intergalactic distances, we are surrounded by histories, not neighbors in the ordinary sense, histories. Distant galaxies are not live windows. They are old letters, some written millions of years ago, some billions, and our telescopes are reading them only now. This makes the night sky feel different. Every galaxy becomes both real and gone. Real because the light is real. Gone because the moment we see is no longer happening there. The universe becomes a library of delayed light. And between the pages, there are gaps so vast that no message can keep up with the present. Now imagine trying to cross such a gap. Even if a civilization were advanced enough to launch a ship toward another galaxy, the destination would not be the galaxy they observed at launch. It would be the galaxy, as it becomes long after that ancient light was emitted. The travelers would be aiming not at a place as seen, but at a place predicted, a future location, a future structure, a system that will have changed by the time they arrive. Space travel always involves prediction, even inside the solar system. Planets move, stars move, galaxies move too. Across millions of years, entire galaxies shift, rotate, interact, and evolve. A journey between galaxies would require navigation on cosmic timescales, not simply pointing at a distant glow, not simply flying toward what the telescope sees, because what the telescope sees is the past. The real destination has moved through time. This is another reason the distance between galaxies is worse than it seems. The target is old light. The destination is future reality. And the journey between them may last longer than anything human civilization has ever sustained. A ship moving through intergalactic space would need to understand not only where a galaxy appears, but where it will be, how gravity will shape its motion, how the expansion of space affects the path, how nearby structures influence the flow, how to correct course across unimaginable time. Navigation would become a science of cosmic patience. And if the mission carried living beings, that patience would become almost impossible, because human minds are not built for million-year journeys. Even human cultures struggle to preserve memory across a few thousand years. Languages change, stories mutate, records decay, buildings collapse, empires vanish, religions transform, knowledge is lost and rediscovered. Now imagine a mission whose travel time is measured not in decades, not in centuries, but in millions of years. How would purpose survive? How would identity survive? How would a crew or their descendants remember why the journey began? A mission to another galaxy would need something beyond engineering. It would need a civilization designed around memory, a way to preserve purpose across time, so long that Earth itself might become unrecognizable. The ship would need archives, education, rituals, systems of governance, conflict resolution, cultural renewal, scientific maintenance, technological continuity. It would need to protect not only bodies, but meaning, because a ship can survive physically and still fail culturally. If the descendants of the original crew no longer believe in the mission, what happens? If they decide the destination is irrelevant, do they turn back? Can they turn back? If they divide into groups, how does a society survive inside a closed vessel? If myths replace history, do they still know where they are going? These questions sound like science fiction, but they become unavoidable when distance becomes that large. The distance between galaxies is not only a challenge for rockets, it is a challenge for civilization itself. To cross intergalactic space, a society would need to become more stable than any society humans have ever built, more patient, more self-sustaining, more careful with memory, more capable of surviving boredom, isolation, and change. The ship would not simply travel through space, it would travel through eras, and every era inside the ship would have to keep the next one alive. This reveals something about galaxies that is easy to miss. They are so far apart that they may divide civilizations not by location only, but by destiny. A civilization inside one galaxy may develop, expand, and transform entirely within that galaxy, without ever needing to cross into another. The galaxy itself may be large enough to contain all its history, all its exploration, all its conflicts, all its futures. The Milky Way alone contains hundreds of billions of stars. Even if only a small fraction have planets, the number of possible worlds is enormous. For any civilization, one galaxy may already be more than enough. Perhaps this is why galactic travel may never be necessary. Maybe the galaxy is the natural scale of a civilization. Planets are homes. Star systems are neighborhoods. Galaxies are continents so vast that crossing beyond them becomes almost meaningless. A species could spend millions of years exploring its own galaxy and still never exhaust it. There would be more stars than any civilization could easily visit, more planets than any culture could fully understand, more histories than any archive could comfortably hold. From that perspective, the distance between galaxies may act as a natural boundary, not an absolute wall, but a practical one, a cosmic border between civilizations. If intelligent life exists in other galaxies, it may remain forever beyond contact in any meaningful way, not because it is rare, not because it is hiding, but because the scale between galaxies prevents shared history. Each galaxy may become its own universe of experience, a cosmic island where life, if it appears, develops its own story almost completely isolated from others. That is a lonely thought, but also a clarifying one. When humans talk about the universe being full of galaxies, we often imagine abundance as closeness. So many galaxies, so many possibilities, but abundance across unreachable distance is not the same as connection. A treasure locked beyond an ocean you can never cross is still real, but it does not change your daily survival. The universe may contain more possibilities than we can imagine, and still keep most of them separated forever. This is the great paradox of galactic distance. The universe is full, but lonely, crowded, but isolated, bright, but separated by darkness. It is possible that billions of planets exist in other galaxies, possible that life exists in some of them, possible that civilizations have appeared under skies we will never see. But their light may be old, their signals may never reach us clearly, their present may be forever inaccessible, and even if we know they might exist, we may never share a moment with them. The distance between galaxies turns possibility into silence. This silence is not empty. It is full of things too far to touch. And that may be more haunting than emptiness. An empty universe would be sad in one way, but a universe full of unreachable islands is sad in another. It means we are surrounded by potential neighbors, separated by time so vast that neighborhood loses meaning. Now think about the Milky Way again, not as a spiral in a picture, but as the entire arena of human possibility. Every human who has ever lived was born inside it. Every myth, every science, every language, every telescope, every spacecraft, every dream of the stars, all inside one galaxy, and even this galaxy remains mostly unknown to us. We have not visited another star. We have barely begun exploring our own solar system. We cannot see through some regions of our own galactic dust in ordinary light. We are still mapping, still learning, still guessing at many hidden structures. So before the distance between galaxies becomes a travel challenge, our own galaxy remains an unfinished mystery. This matters because it changes the emotional scale. The distance to another galaxy is not the next step after reaching the stars. It is many steps beyond steps we have not yet taken. First, humanity must survive on Earth, then become secure in the solar system, then reach nearby stars, then learn to live across interstellar distances, then perhaps spread through parts of the Milky Way. Only after all that would the edge of the galaxy become a real horizon. And beyond that horizon, another ocean begins. So when we say the distance between galaxies is worse than you think, it is not simply because the numbers are large. It is because those numbers sit beyond an entire ladder of impossible tasks. Each rung is difficult. Each one may take centuries or millennia. And the final leap to another galaxy may remain beyond anything we can honestly plan. This creates a strange humility. The universe is not offering one challenge. It is offering layers of challenge, planetary distance, interstellar distance, galactic scale, intergalactic voids, cosmic expansion, the observable horizon. Each layer makes the previous layer feel smaller, and the human mind must keep adjusting. But there is another side to this. Even if we cannot cross between galaxies, we can still learn from them. This is one of the most beautiful facts about astronomy. We may be physically limited, but light carries stories to us. Galaxies send their histories across space. Their shapes tell us about mergers. Their colors tell us about stars. Their spectra reveal chemistry. Their motion reveals mass. Their light reveals age. Even when we cannot travel, we can understand. Not completely, not perfectly, but enough to transform darkness into knowledge. A telescope becomes a kind of impossible ship. It does not carry our bodies, but it carries our attention. It lets human consciousness move beyond the Milky Way without leaving Earth. It lets us study galaxies that no spacecraft may ever reach. And in that sense, astronomy is humanity's first form of intergalactic travel. Not travel of matter, travel of mind. We look across the void. We receive ancient light. We turn faint photons into maps, images, equations, and stories. We reconstruct events that happened before human beings existed. We learn how galaxies form, evolve, collide, and die. We learn where stars are born, where black holes grow, where matter gathers, where voids open. This kind of travel may not satisfy the dream of standing on another world, but it is still profound. A creature on one small planet can understand galaxies millions and billions of light years away. That should not feel ordinary. It is almost miraculous. The same universe that separates galaxies also allows light to cross the separation. It hides the present, but reveals the past. It denies us arrival, but grants us evidence. And maybe that is the compromise the universe offers. You may not cross every distance, but you may learn what lies across it. You may not enter every galaxy, but you may see its ancient light. You may not share its present, but you may understand part of its story. For now, that is how humanity reaches galaxies. Through instruments, through patience, through mathematics, through silence. But even this form of reaching has limits. As the universe expands, some light will never arrive. Some galaxies are beyond our future visibility. Some regions are already causally disconnected in a way that prevents any signal sent now from ever reaching us. The observable universe is not the whole universe. It is the part from which light has had time to reach us since the beginning. Beyond that, there may be more, perhaps much more, but we cannot see it. Not because it is dark, not because it lacks galaxies, but because its light has not reached us and may never reach us. This means the distance between galaxies is only part of the greater mystery. Beyond visible galaxies are unseen galaxies. Beyond reachable light are unknown regions. Beyond the observable universe may be distances that have no practical meaning to us at all. No image, no signal, no contact, no possible confirmation. The universe does not simply place galaxies far away. It places a horizon around what can be known, and that horizon is one of the deepest boundaries in science. A boundary not made of matter, but of time, expansion, and light. To live in the universe is to live inside a visible bubble. A cosmic window. We can see far, but not infinitely far. We can infer much, but not everything. We can map the observable, but not the total. And galaxies near the edge of that window remind us that distance eventually becomes disappearance. A faint galaxy in the deepest image may be a real object, but it is also near the edge of what the universe allows us to witness. Its light has traveled for billions of years, stretched by expansion, weakened by distance, shifted into wavelengths our eyes cannot see. By the time we detect it, it is not just a galaxy. It is a message from a younger universe, a message almost lost. This is why the distance between galaxies carries a kind of melancholy. Every distant light is precious because it survived the crossing. Every photon from another galaxy is a traveler older than human history. It crossed emptiness. It passed through expanding space. It avoided absorption. It entered a telescope. It became knowledge. A single photon from a galaxy millions or billions of light years away has completed a journey no human object may ever match, and yet it arrives silently, without drama. A tiny piece of ancient starlight. This is the beauty hidden inside impossible distance. The same distance that humbles us also delivers the universe to us, not as touch, not as travel, but as light. And light is enough to begin wonder. Still, wonder does not erase the scale. If anything, it makes the scale stronger. Because the more we know about galaxies, the more we understand how separated they are. The more detailed our maps become, the more enormous the gaps appear. The cosmic web is beautiful, but it is not human-sized. It is not built for travelers like us. It is built by gravity, dark matter, expansion, and time. Galaxies move within it like bright foam on an invisible sea. Clusters gather, voids expand, filaments stretch, and humanity watches from one small point, trying to understand a structure larger than imagination. Part 3 brings us into that larger structure, beyond the simple question of one galaxy and another, beyond the first shock of Andromeda, beyond the idea of galaxies as isolated lights. Here, galaxies become part of a cosmic landscape, a web of matter, a pattern of brightness and emptiness, a universe where distance shapes knowledge, travel, communication, identity, and fate. And once you see galaxies this way, the title becomes even more true. The distance between galaxies is worse than you think, because it is not only the space between them, it is the time between their moments, the silence between their possible civilizations, the void between their histories, the expansion pulling many of them away, the limits of any journey, the fragility of memory across deep time, the boundary between what can be seen and what can be reached. A galaxy is not only far because it is millions of light years away, it is far because its present is hidden, its future is separate, its possible life is unreachable, its light is ancient, its distance is wrapped in time. And still, from Earth, we look. We look because the darkness is not empty. We look because every faint glow carries a story. We look because our galaxy is only one island, and the sky is filled with others. We look because distance has always frightened humans, but it has never fully stopped us from wondering. Maybe no human will ever cross the gulf between galaxies. Maybe no ship will ever leave the Milky Way and arrive in Andromeda with living minds aboard. Maybe intergalactic travel will remain forever beyond biology. But even if that is true, the galaxies still matter. They tell us that reality is larger than reach. They tell us that the universe does not need to be accessible to be meaningful. They remind us that existence is not limited to what humans can touch. And perhaps that is the deepest lesson of all. The universe is full of places that may never become destinations, full of lights that may never become homes, full of histories that may never become conversations, full of galaxies that shine across darkness, not waiting for us, not calling to us, but simply existing, ancient and immense, beyond the edge of our possible journeys. And that may be enough to change us, because to understand the distance between galaxies is to understand that humanity lives inside a universe much larger than ambition, a universe where curiosity travels farther than bodies, where light travels farther than life, where knowledge reaches across voids that no ship may cross, and where every galaxy in the distance is both a promise and a warning. A promise that the universe is rich beyond imagination, and a warning that richness does not mean closeness. The cosmic web is full of light, but the spaces between those lights are deep enough to make even the boldest civilization feel small. And maybe, in the end, that smallness is not defeat. Maybe it is perspective, a reminder that we are not the center, not the measure, not the purpose of the galaxies. We are witnesses, brief witnesses, standing on a small planet inside one galaxy, watching ancient islands of stars shine across an ocean we may never cross. And still, we keep watching. There is another way to understand the distance between galaxies. Not by imagining a ship crossing the void, not by counting light years, not by looking at a photograph full of tiny glowing spirals, but by asking a stranger question. What holds galaxies together across so much emptiness? Because when we look at the universe on the largest scales, we see separation everywhere. Galaxies divided by darkness, clusters floating far apart, voids opening like enormous black oceans between the bright structures of matter. But the universe is not simply a collection of isolated islands. It is connected, quietly, invisibly, through gravity, through dark matter, through streams of gas, through ancient history, through forces that do not care whether humans can see them. And this is where the distance between galaxies becomes even more mysterious, because galaxies are far apart, but they are not completely independent. They pull on each other, they orbit, they collide, they merge, they stretch each other into strange shapes. They steal stars. They tear gas loose. They build bridges of matter so faint that human eyes would never see them without instruments. In a normal image, a galaxy looks self-contained, a spiral disk, a glowing center, a clean shape against blackness. But that is often an illusion. Many galaxies carry scars, long tidal tails, distorted arms, streams of stars, evidence that gravity reached across space and changed them. Even when two galaxies are separated by enormous distances, their gravity can slowly begin a conversation. Not a conversation in sound, not a signal, a gravitational conversation. One galaxy pulls, the other responds. Their shapes change, their paths curve, their futures become linked. This is one of the strangest facts about galactic distance. The space between galaxies can be vast, and still not enough to keep them apart forever. Gravity is patient. It does not need speed. It does not need drama. It works slowly across time, and time in the universe is abundant. A galaxy interaction can take hundreds of millions of years. A merger can take billions. From a human point of view, that is almost eternal. But for galaxies, it is part of their lives. They are born, they grow. They consume smaller galaxies. They collide with larger ones. They change shape. They become something new. A spiral may become distorted. Two galaxies may become one. A quiet system may awaken with bursts of star formation. Gas may fall towards the center, feeding a supermassive black hole. Stars may be thrown into long streams, glowing faintly, like torn fabric in the dark. Distance does not stop this. It only slows the story. That is why galaxies feel both isolated and connected. They are separated by vast emptiness, but bound by invisible influence. And perhaps the best place to see this is inside galaxy clusters. A galaxy cluster is not one galaxy. It is a city of galaxies, hundreds or even thousands of galaxies gathered in one gravitational region. Compared to the full universe, a cluster is dense. But dense does not mean close in the way humans imagine. Even inside a cluster, the galaxies are separated by enormous distances. A single cluster can span millions of light years. The galaxies inside it can move at incredible speeds. They can pass near each other. They can pull on one another. They can distort each other over time. But between them remains space on a scale larger than anything inside our daily lives. If you were somehow inside a galaxy cluster, the sky might be richer. You might see more galaxies spread across the dark, some larger, some brighter, some closer than the galaxies visible from Earth. But close in astronomy is a strange word. A galaxy that appears beautifully large in the sky may still be hundreds of thousands of light years away. A neighboring galaxy inside a cluster may still be farther than anything humans could hope to reach. A cosmic city is not like a human city. Its buildings are galaxies. Its streets are light years. Its neighborhoods are measured in distances that swallow civilizations. And yet, clusters are not empty. They contain something most people never imagine. Hot gas, extremely thin, extremely spread out, but real. Between the galaxies in a cluster, there can be vast amounts of gas heated to enormous temperatures. This gas does not form familiar clouds like those in Earth's sky. It is too diffuse, too huge, too hot. It fills the cluster like an invisible atmosphere, shining in X-rays that human eyes cannot see. In some clusters, there may be more ordinary matter in this hot gas than in the galaxies themselves. Think about that. A cluster may look like a collection of galaxies, but much of its matter may be hidden between them. Not in stars, not in planets, not in the space we would usually call empty. This changes the feeling of intergalactic distance. The void between galaxies is not always nothing. Sometimes it is filled with material too thin to notice in ordinary light. Gas, plasma, magnetic fields, radiation, dark matter. The visible galaxies are only the brightest pieces. The hidden environment between them can contain enormous mass. Again, space hides its truth. It makes the bright objects obvious and the connecting material almost invisible. But invisible does not mean unimportant. The hot gas inside clusters can tell astronomers how massive the cluster is. It can reveal collisions between galaxy clusters. It can show shock waves larger than galaxies. It can trace the history of enormous gravitational events. And surrounding all of this is dark matter, the unseen structure that helps hold galaxy clusters together. Without dark matter, many clusters would not behave as they do. The visible galaxies and gas alone are not enough to explain the gravity we observe. Something else dominates the mass, something that does not shine, something that does not reveal itself directly through ordinary light. This makes the distance between galaxies even more unsettling, because the galaxies we see may be moving through a much larger, invisible structure, a dark framework, a gravitational skeleton. The bright galaxies are like lanterns placed along something we cannot see. The cosmic web itself may be shaped largely by dark matter. Galaxies form where matter gathers. Clusters appear where filaments meet. Voids open where matter is sparse. But the visible universe is not the full structure. It is the glowing trace of something deeper. When we talk about the distance between galaxies, we are often imagining the distance between the visible parts, the spirals, the bright centers, the star-filled disks. But the real cosmic landscape includes invisible halos that stretch far beyond those visible edges. A galaxy's dark matter halo can extend far outside the region where most of its stars shine. A cluster's dark matter can create a vast gravitational field around many galaxies. This means galaxies may be separated by bright emptiness while still embedded inside overlapping dark structures. They may look isolated, but gravity links them in ways our eyes cannot follow. This is one reason gravitational lensing is so powerful. When light from a distant galaxy passes near a massive galaxy or cluster, its path can bend. The mass between us and the distant object warps space-time, changing the route of the light. A galaxy cluster can act like a cosmic lens. It can magnify galaxies far behind it. It can stretch their images into arcs. It can create multiple images of the same distant object. It can reveal background galaxies that would otherwise be too faint to study. This is one of the most beautiful effects in astronomy. A massive structure in space bends the light of something even farther away. Distance, gravity, and light become tangled. A galaxy cluster becomes not only an object, but a window, a natural telescope, a structure that lets us see deeper into the universe, because its gravity bends space itself. And that tells us something profound. The distance between galaxies is not just empty separation. It is a landscape where light travels through curved spacetime, where mass changes what we see, where a galaxy can distort the image of another galaxy far behind it, where the universe uses its own gravity to reveal hidden depths. This is why space can never be understood as a simple black background. The darkness between galaxies has shape, not visible shape, gravitational shape. A beam of light crossing the universe does not simply move through nothing. It travels through expanding space, past clusters, past dark matter halos, past regions of different density, past invisible gravitational fields. By the time that light reaches Earth, it may carry the marks of everything it passed. Its color may be stretched, its path may be bent, its brightness may be changed, its image may be distorted. A distant galaxy is not just seen, it is filtered by the universe between us and it. And that universe between is enormous. This makes every deep image of space feel more mysterious. When we look at a distant galaxy, we are looking not only at that galaxy, but through millions or billions of light years of cosmic history. The light had to survive the crossing. It had to pass through the web of matter. It had to travel as space expanded. It had to arrive at our instruments with enough information still intact for us to understand it. Every image is a triumph over distance. Every faint galaxy is a message that survived a journey almost beyond comprehension. And yet, the farther we look, the more fragile that message becomes. Details fade. Light stretches. Galaxies become smaller. What was once visible becomes infrared. What was once bright becomes faint. The early universe hides behind distance, not because it wants to be hidden, but because light changes while crossing expanding space. This is why some of the most distant galaxies require telescopes designed to see infrared light. Their original ultraviolet and visible light has been stretched by the expansion of the universe. By the time it reaches us, it is no longer the same kind of light it was when it began. The universe itself has changed the message. This means distance does not simply delay light, it transforms it. A galaxy far away is not just old, it is redshifted. Its light stretched like a long note, lowered in pitch. And from that stretching, astronomers learn how far it has traveled, how far space has expanded, and how ancient the galaxy may be. Distance becomes a clue. A distortion becomes information. The universe hides its scale inside the light itself. But the same effect that helps us measure the cosmos also reminds us of separation. The more red-shifted a galaxy is, the farther and older it usually is. The more stretched the light, the more the universe has expanded during its journey. So a faint red smudge in a telescope image may be a galaxy from a time when the universe was young, not a nearby object, not a small object, a great structure seen from across almost all of cosmic history. This is one of the strangest reversals in astronomy. The faintest things can be the most enormous. The smallest specks can be whole galaxies. The dimmest light can carry the oldest stories, and the black spaces between them may contain more than our eyes can ever know. If humans could travel between galaxies, they would not experience the universe the way a telescope does. They would be inside the gap, inside the distance. A telescope compresses millions of years into an image. A ship would have to live through the crossing. That difference is everything. An image of Andromeda arrives in an instant on a screen. The real distance to Andromeda would take light itself millions of years. This gap between image and reality is one reason the universe feels deceptive. We can place a galaxy on a thumbnail. We can zoom in on it. We can animate a line from the Milky Way to Andromeda. We can make the journey appear understandable, but the actual scale remains untouched by the image. A line on a screen can represent 2.5 million light years, but the line does not feel like 2.5 million years of light travel. It feels like a line. That is the danger of cosmic visualization. It helps us understand, but it also protects us from the full terror of scale. If every diagram showed the real proportions, most of it would be empty. If every animation moved at realistic speed, most of it would feel still. If every galaxy image communicated true depth, the human mind would struggle to hold it. So astronomy must simplify. But behind every simplification is a reality far more severe. The distance between galaxies is not a clean line. It is a gulf of space-time. And within that gulf, even the rare objects become fascinating. There are stars that do not belong clearly to any single galaxy. Some have been thrown out by gravitational interactions. Some may drift through the spaces between galaxies. Inside galaxy clusters, there is intracluster light, a faint glow from stars that wander between galaxies after being stripped from their original homes. These stars are not inside a familiar stellar neighborhood like the Sun. They are lonely lights in the spaces between galaxies. Imagine a planet orbiting such a star. If one survived, its night sky might be deeply strange. No bright Milky Way band overhead, no nearby crowded disk of stars, only distant galaxies scattered across a black sky. A world not truly inside a galaxy, but between galaxies. Such places, if they exist, would be among the loneliest environments imaginable. A star exiled from its home galaxy, a planet circling it in the dark, a sky where galaxies are distant islands instead of a surrounding city of stars. This is a rare and speculative image, but it reveals the emotional power of intergalactic space. Even the objects inside it feel exiled, not because the universe has emotions, but because humans cannot help reading isolation into distance. A star between galaxies is still obeying physics, still shining, still existing, but to us, it feels abandoned. A candle between continents. This is what the distance between galaxies does to imagination. It turns even light into loneliness. But not everything between galaxies is passive. Sometimes, galaxies interact so violently that they throw matter outward. Tidal streams can stretch for huge distances. Gas can be stripped away from galaxies moving through clusters. Jets from supermassive black holes can extend far into intergalactic space, injecting energy into the surrounding medium. A galaxy cluster can contain shock waves, turbulence, and enormous structures created by collisions and gravitational interactions. From far away, a cluster may look peaceful, a collection of soft, glowing galaxies. But in X-rays, radio waves, and gravitational maps, it can reveal violence on scales almost impossible to imagine. Clusters collide, not like solid objects smashing, but like enormous gravitational atmospheres passing through one another. Gas clouds crash and heat. Dark matter moves differently from ordinary matter. Galaxies pass through the chaos like sparks moving inside a storm. The collision can take hundreds of millions of years. The aftermath can teach us about dark matter, gas physics, and the structure of the universe. This is another reason galactic distance is so difficult. The events are not only huge in space, they are huge in time. A galaxy cluster collision is not an explosion that happens in a moment. It is a slow catastrophe, a cosmic event so large that if humans could watch it directly, one lifetime would show almost nothing. The universe's greatest dramas often unfold too slowly for biology. We have to reconstruct them from evidence, from snapshots, from light arriving at one time, from simulations, from comparison. We see a cluster as it is in one ancient moment, then use physics to understand what happened before and what may happen after. Astronomy is often the science of incomplete scenes. We do not watch the whole movie. We receive frames, and the distance between galaxies makes the frames arrive old. This adds another layer to the problem. The universe is not only too large to cross easily, it is too slow to watch directly in human time. Galaxies merge over billions of years. Clusters evolve over vast timescales. Superclusters stretch and change across cosmic history. Voids grow as the universe expands. The large-scale structure is alive in the gravitational sense, but its motion is almost frozen to us. We see change by comparing objects at different distances and therefore different times. The deeper we look, the earlier the universe appears. So distance becomes a time machine, but an imperfect one. We cannot watch one galaxy evolve from youth to old age directly. We study many galaxies at many distances, and from them we build a story. Nearby galaxies show later stages. Distant galaxies show earlier stages. Together, they become a cosmic timeline. This is one of the most powerful uses of galactic distance. It lets us see history, not by traveling into the past, but by receiving light that left long ago. A galaxy 5 billion light-years away appears as it was 5 billion years ago. A galaxy 10 billion light-years away appears as it was when the universe was much younger. Distance gives us ancient views. The farther we look, the younger the universe becomes. This is beautiful, but also limiting, because we can never see the present of those far galaxies. We can see their past. We can infer their future, but their now is beyond us. That word, now, becomes almost fragile at cosmic distances. On Earth, now feels universal. We imagine everything happening together in one present. But the universe does not give us access to one shared present across enormous distances. The galaxies we see are scattered across time. Each one is an old message. Each one belongs to a different cosmic moment. A deep field image is not a photograph of the universe at one time. It is a stack of different times. Nearby galaxies, as they were recently, farther galaxies as they were long ago, the deepest galaxies as they were near the beginning. One image becomes a vertical slice through history, and the distance between galaxies becomes the distance between epochs. This is why saying galaxies are far apart is almost too simple. They are far apart in space. They are far apart in time. They are far apart in evolution. A nearby galaxy may be mature. A distant galaxy may be young. A cluster nearby may be settled. A cluster far away may still be forming. The universe at one distance is not the same age as the universe at another distance. Distance changes the stage of cosmic life we are seeing. And so, as we look across intergalactic space, we are not just looking at different places. We are looking at different versions of the universe. The universe as it was 1 billion years ago, 5 billion, 10 billion, more. This gives us knowledge no traveler could easily collect by moving locally. A ship crossing space would be trapped in its own time, but a telescope can look far and see old light. In this sense, distance is both barrier and archive. It prevents arrival, but it preserves history. The light from ancient galaxies arrives like evidence in a cosmic investigation. Without those distances, we would not see the early universe. Everything would appear only as it is nearby. But because light takes time to travel, the universe allows us to observe its own past. This is one of the deepest gifts, hidden inside impossible scale. Galactic distance is terrifying, but it is also why cosmology is possible. Without the delay of light, the sky would not be a record. It would be only a view, but because of distance, the sky is history. Still, for travel, this gift becomes a problem. A civilization trying to reach another galaxy would be aiming at a target known through old information. The farther the galaxy, the older the map. Imagine planning a voyage using a photograph millions of years out of date. The galaxy has moved. Its internal structures have changed. Stars have died. New stars have formed. Black holes may have fed. Satellite galaxies may have merged. The destination may still exist, but not exactly as seen. This does not make navigation impossible in principle, but it makes it deeply complex. At cosmic scales, every map is historical. Every route is a prediction. And the longer the journey, the more the destination belongs to the future, not the image. That is another reason intergalactic travel feels almost mythological. It asks a civilization not only to move across distance, but to predict the future of cosmic structures, to launch into darkness based on models, to trust physics across millions of years, to believe that the destination will still matter when arrival finally comes. This level of commitment is beyond anything humans have done. Our longest-lived institutions are brief. Our oldest monuments are young compared to cosmic time. Our species itself is young. Human civilization, as we know it, is a flicker. And yet, galaxies move on timescales where that flicker is almost invisible. This is why looking at galaxies can make human history feel delicate. Everything we call ancient is recent to a galaxy. The pyramids are young. The first writing is young. The first cities are young. The first telescopes are almost nothing. Even the entire existence of our species is brief compared to the crossing time between galaxies. The light from Andromeda began its journey before the history we recognize as civilization. And that is only a nearby galaxy. Farther galaxies send light from times before Earth's continents looked as they do now, before mammals dominated, before complex life in some cases. Depending on distance, some light began traveling before the sun was born. To receive that light is to be touched by a history older than home. This makes galaxies feel almost sacred, not in a religious sense, necessarily, but in the sense of scale. They are ancient structures carrying light across durations longer than the entire human story. They existed before us. They will continue after us. They do not need us to observe them. But somehow, for a brief moment, we do. A species on a small planet opens its instruments and catches ancient light from islands of stars across the universe. That should make us quiet, because the distances between galaxies are not only obstacles, they are reminders of how brief our awareness is. The universe spent billions of years without humans. Galaxies formed, collided, evolved, and shone long before any mind on Earth named them. And if humanity disappears one day, galaxies will continue. Andromeda will still move toward the Milky Way. Clusters will still evolve. Voids will still expand. Distant galaxies will still drift beyond horizons. The cosmic web will not pause. This can feel frightening, but it can also feel calming. Our smallness does not make existence meaningless. It gives our questions a strange beauty. We are brief, and yet we can understand things almost unimaginably old. We are small, and yet we can map structures almost unimaginably large. We cannot cross the spaces between galaxies, but we can know they are there. We can measure them. We can imagine them. We can feel humbled by them. And maybe that is one of the highest forms of human experience. To stand in one place and realize how far reality extends beyond it. This brings us back to the image of galaxies in the night. A glowing spiral, a faint oval, a cluster of distant lights. They look peaceful, but behind that peace is scale. A scale so immense that the distance between galaxies becomes a kind of cosmic silence. Not empty silence, a silence filled with history, gravity, gas, dark matter, light, old messages, invisible structures, wandering stars, faint bridges, expanding space. Every galaxy is part of a story larger than itself. Every gap contains more than emptiness, and every distance reminds us that the universe is connected in ways our eyes cannot easily see. This is the hidden contradiction. Galaxies are separated, but not isolated. They are distant, but not meaningless to one another. They are divided by voids, but joined by gravity and cosmic history. The Milky Way did not form alone in a blank universe. It formed inside a web. It grew by gathering matter. It absorbed smaller systems. It moves with its group. It is shaped by dark matter. It is on a path toward Andromeda. It is one node in a vast structure, and every other galaxy has its own version of this story. No galaxy is simply floating alone without context. Even the loneliest galaxy belongs to the history of the universe. This may be the most important idea in Part 4. The distance between galaxies is not just separation. It is relationship stretched across unimaginable scale. Gravity can reach where travel cannot. Light can cross where bodies cannot. History can connect what communication cannot. The universe is filled with gaps, but the gaps are part of the structure. The spaces between galaxies are not mistakes. They are not empty margins. They are essential to the way the cosmos is built. Without distance, galaxies would not be galaxies in the same way. Without emptiness, structure would not have shape. Without voids, filaments would not stand out. Without separation, there would be no cosmic web. So the very thing that makes the universe feel impossible also gives it form. Distance is not only an obstacle. Distance is architecture. The darkness between galaxies is part of the design. It allows galaxies to exist as islands, clusters as cities, voids as oceans, filaments as roads of matter, and the whole universe as a web of light and shadow. For humans, that distance feels cruel because it places so much beyond reach. But from the view of the universe, distance is how structure exists. It is how gravity writes on the largest canvas. It is how matter becomes patterned instead of uniform. It is how cosmic history leaves room for galaxies to grow, move, merge, and separate. And perhaps that is why the distance between galaxies is worse than we think. Because it is not simply far. It is fundamental. It is woven into the shape of everything. It defines what can interact, what can communicate, what can merge, what can be seen, what can be reached, what can be known only through ancient light. A galaxy is a place, but the distance around it is part of its identity. The Milky Way is not only the stars inside it, it is also its position in the local group, its path toward Andromeda, its place in the cosmic web, its separation from other clusters, its view of the universe. And Earth's view of the cosmos is shaped by that position too. We are where we are, inside one galaxy, at one time, looking outward through one window. And the distances between galaxies decide what that window shows. In another region of the universe, the view would be different. In another era, the view would be different. In the far future, the view may be darker. In the early universe, the view would be brighter with young formation. We see the universe from one moment in its history, a moment when galaxies are visible across deep space, a moment when the cosmic web can be mapped, a moment when distant light still arrives. That moment is precious because it will not last forever. As expansion continues, many galaxies will become harder to see. The distant universe will fade beyond reach. Future skies may lose the evidence that now fills our telescopes, and perhaps beings in the far future, if they exist, will look into darkness and never know how crowded the universe once appeared, unless they inherit records from civilizations like ours. That thought makes our observations feel almost like preservation. Every deep field image, every galaxy survey, every map of the cosmic web, every measurement of expansion, every record of ancient light These are not only scientific achievements, they are memories of a universe still visible, a universe before the farthest galaxies disappear beyond practical observation. We are recording the cosmic ocean while its distant ships are still in sight, and that may be one of humanity's quiet roles, not to cross every distance, not to conquer every galaxy, but to witness, to receive light, to preserve knowledge, to understand the structure around us while it can still be seen. The distance between galaxies may never become small, but our understanding of it can grow. And in that understanding, the universe becomes both more unreachable and more intimate. More unreachable because the numbers are overwhelming. More intimate because we can see the pattern. We can learn the story. We can recognize that the Milky Way is not alone, that Andromeda is approaching, that clusters form, that voids open, that dark matter shapes the web, that light carries ancient truth across the dark. We may never stand between galaxies, but we can know that intergalactic space is not merely an empty absence. It is part of the cosmos. It carries gas, it carries radiation, it carries gravity, it carries the paths of ancient light, it carries the memory of interactions, it carries the invisible shape of dark matter, it carries the silence between islands, and that silence is enormous. So enormous that every galaxy we see becomes more precious. A galaxy is not just a light, it is a civilization of stars separated from us by a journey almost beyond meaning. A structure held together by gravity, a history written in starlight, a present we cannot access, a future we can only model, and a distance that reminds us how much of reality will always exceed the reach of human hands. This does not make astronomy sad. It makes it profound. Because perhaps the universe is not asking us to reach everything. Perhaps some things are meant to be known from afar, not owned, not touched, not entered, only witnessed. And there is dignity in witnessing. A small planet, a brief species, a sky full of ancient galaxies, and minds capable of understanding that the lights they see are separated by oceans of time. That is not failure. That is wonder. The distance between galaxies is worse than we think, because it is not just the distance between objects. It is the distance between histories, between presents, between possible civilizations, between what can be seen and what can be reached, between what exists and what can ever be shared. But it is also the reason the universe has depth, the reason the sky is history, the reason light becomes memory, the reason galaxies appear as ancient islands across the dark. And perhaps, when we look at them honestly, we begin to understand our place a little better. We are not standing at the center of everything. We are standing on a shore. Behind us, Earth. Around us, the Milky Way. Ahead of us, a cosmic ocean filled with islands of stars, some near enough to see, most too far to ever reach. All of them part of a universe whose silence is not empty, but immeasurably vast. There is a future waiting for the galaxies, a future so distant that no human life can touch it, so slow that, from our point of view, it almost looks frozen, but it is there, quietly unfolding. The Milky Way is not still. Andromeda is not still. The galaxies around us are not fixed lights placed forever in the dark. They are moving through gravity, drifting, falling, approaching, changing, and one day, far beyond the age of every city humans have ever built, our galaxy and Andromeda will meet. Not tomorrow, not in 1,000 years, not even in 1,000,000, but billions of years from now. The two great galaxies of our local cosmic neighborhood will begin to collide. And this collision is one of the most important reminders of what galactic distance really means. Because Andromeda is incredibly far away, about 2.5 million light years. Its light reaches us from a past older than human civilization itself. And yet, despite that distance, gravity is pulling it toward us, slowly, patiently, across cosmic time. That is the strange contradiction of the universe. Galaxies can be separated by distances so vast they feel unreachable, and still be connected by fate. The Milky Way and Andromeda are not random strangers in the dark. They are part of the same gravitational story. The distance between them is enormous, but not eternal. One day, that distance will shrink, and when it does, the night sky, if Earth still exists in any recognizable way, would change beyond imagination. Andromeda, which now appears as a faint smudge in dark skies, would grow larger over millions and millions of years. At first, barely noticeable, then clearer, then huge, a great glowing structure spreading across the night, its spiral arms visible, its bright center rising like a second Milky Way. The sky would no longer feel like the sky we know. It would become a scene from a future universe, two galaxies approaching, two islands of stars preparing to become one. But the word collision is misleading. When humans hear collision, we imagine impact, destruction, objects smashing together. But galaxies are mostly empty space. The stars inside them are separated by such enormous distances that when two galaxies merge, most stars will not crash into each other. The Sun, if it still exists in some future stage, would almost certainly not collide directly with another star. Instead, gravity would do the work, slowly reshaping everything. Stars would be pulled into new orbits. Gas clouds would compress. New stars might form in great bursts. The shapes of both galaxies would distort. Long streams of stars could be thrown outward. The beautiful spiral structures would twist, stretch, and eventually dissolve into something new. The Milky Way would lose its familiar identity. Andromeda would lose its familiar identity. Together, they would form a new galaxy, a larger one, a merged remnant. Sometimes people call it Milky Way, a future galaxy born from the meeting of our own and its nearest giant neighbor. This future merger tells us something profound. Galaxies are not permanent in the way they appear. They look majestic, stable, and ancient. But they are living structures in the gravitational sense. They grow by merging. They change by absorbing smaller galaxies. They are shaped by encounters. They carry the memory of past collisions in their stars, halos, streams, and motions. The Milky Way itself has already consumed smaller systems, and it will continue changing. Our galaxy is not a finished object. It is a chapter, and Andromeda is part of its future. But if the Milky Way and Andromeda are destined to meet, why does galactic distance still feel so impossible? Because the timescale is beyond human meaning. Billions of years, that is the key. Gravity can cross galactic distances, but only with time so enormous that human history becomes almost invisible. What is impossible for a spacecraft may still happen naturally through cosmic patience. The universe does not need fast motion to transform itself. It has time, an amount of time the human mind struggles to hold. This is why galaxies can look peaceful while moving toward enormous change. From Earth, Andromeda seems still, a faint oval in the sky. But that stillness is an illusion created by our short lives. If we could watch for millions of years, the sky would slowly rewrite itself. And if we could watch for billions, galaxies would become fluid, not frozen islands, but evolving systems, changing shape across ages. The problem is not that galaxies do not move. The problem is that we do not live long enough to feel their movement. And this is one of the deepest lessons of galactic distance. The universe is active on timescales that make humans feel like sparks. A galaxy merger can be one of the largest events in the cosmos and still unfold too slowly for any person to watch directly. A human life is too short to see the motion. A civilization may be too young to remember the beginning. Even species may rise and disappear, while galaxies continue their ancient dance. This makes the future of the Milky Way feel both beautiful and unreachable. We can calculate it, we can simulate it, we can imagine it. But we will not stand under that final merged sky. At least, not as we are now. Not as ordinary humans living ordinary lives. The future belongs to scales we can understand scientifically, but not experience personally. That is what makes astronomy so strange. It lets the mind travel where the body cannot. It lets us imagine billions of years as if they were chapters. But the body remains here, small, temporary, bound to a narrow moment in cosmic history. And yet, our moment is special in its own way, because we live before the merger, before the Milky Way and Andromeda become one, before the distant galaxies vanish from future skies, before cosmic expansion hides much of the universe from future observers. We live in an era where the larger universe is still visible, where telescopes can see beyond our galaxy, where deep fields reveal thousands of distant galactic islands, where the cosmic web can be mapped, where ancient light still arrives from far beyond our local neighborhood. This may not always be true. On very long timescales, the expansion of the universe changes what can be seen. Galaxies outside our gravitationally bound region will continue to move away. Their light will become more stretched, more faint, harder to detect. Future civilizations living in the galaxy formed by the Milky Way and Andromeda may look outward and see a much darker universe. The distant galaxies we see today may no longer be visible to them, not because they are gone, but because the expansion of space has carried them beyond practical observation. The cosmic horizon will have swallowed their light. In that far future, the sky may feel emptier. A civilization could look out into deep space and see mostly its own great, merged galaxy. the rest of the universe hidden by distance and expansion. If no ancient records survived, they might believe their galaxy was all there is. They might not know the universe once appeared, crowded with galaxies. They might not imagine a cosmic web. They might not see the deep fields that humble us today. They might live inside a darker, more isolated cosmic age. This thought is haunting because it means knowledge depends on when you exist, not only where, when. A civilization born too late may miss evidence that is visible to us now. A sky that teaches us abundance may teach future beings isolation. The universe is not only expanding physically, it is changing what can be known. And so, our observations today become a kind of preservation. Every galaxy survey, every deep image, every measurement of cosmic expansion, every map of distant clusters and voids, all of it becomes a record of a universe that future eyes may not see in the same way. In a sense, humanity is taking photographs before the lights fade beyond the horizon. We are recording the universe while it is still open enough to reveal itself. That gives astronomy a quiet urgency. Not urgency like danger, not urgency like disaster, but urgency in the sense that this era is temporary. The window is open now. Ancient light is arriving now. The galaxies are visible now, and we are here now, with minds capable of asking what they mean. This is one of the most beautiful things about our place in cosmic time. We are not at the center of the universe. We are not important in size, but we exist at a moment when the universe can still tell us a large part of its story. That story is written in light, and the distance between galaxies is what allows the story to arrive. If galaxies were close and light arrived instantly, we would see only the present. But because they are far, we see history. We see galaxies at different ages. We see young galaxies forming in the early universe. We see mature galaxies nearby. We see collisions, clusters, and structures at different stages. The sky becomes a timeline. A single deep image can contain galaxies from many eras, some close in cosmic terms, some ancient, some so distant that their light has traveled for most of the age of the universe. The distance that separates us from galaxies is also the distance that preserves their past. This is the paradox. Galactic distance blocks travel, but enables cosmic memory. It keeps galaxies beyond reach, but sends their old light into our instruments. It separates us from their present, but reveals their history. A galaxy is both unreachable and available. Unavailable has a destination. Available has light. And perhaps that is the only form in which most galaxies will ever belong to us, not as places we visit, but as stories we read. Stories written across wavelengths, visible light, infrared, radio, X-rays, gravitational traces, the shape of a spiral arm, the color of old stars, the glow of hydrogen gas, the bending of background light, the motion of galaxies inside clusters, the redshift stretching ancient signals. Every measurement becomes a sentence in a cosmic language, and slowly, from those sentences, we build an understanding of the universe. But this understanding comes with humility, because even when we study galaxies, we do not see everything. We see what light reveals. We infer what gravity suggests. We model what cannot be touched. We estimate what cannot be visited. There is always distance between the real galaxy and our knowledge of it. That distance is not only physical, it is interpretive. A telescope gives us evidence. Science turns evidence into understanding. But understanding is always refined, always revised, always incomplete. A distant galaxy may appear as a faint dot in one instrument, then become a structured object in another. A galaxy once thought ordinary may reveal an active black hole. A faint smudge may turn out to be a massive ancient system. A cluster may reveal hidden mass through lensing. Every new telescope deepens the image, and every deeper image reminds us that the universe was more complex than we thought. This is why galaxies keep changing in human imagination. At first, they were nebulae, faint clouds. Then we understood that many of them were entire galaxies beyond the Milky Way. Then we learned that galaxies evolve, that they merge, that they contain supermassive black holes, that they form stars in waves, that they are shaped by dark matter, that they belong to a cosmic web, that they stretch across time. Each discovery made the universe larger, not always in physical size, but in meaning, and the distance between galaxies became more than empty space. It became a clue to the history of everything, because galaxies did not form randomly. They emerged from the early universe. Tiny fluctuations in matter grew under gravity. Dark matter gathered first, forming invisible wells. Gas fell into those wells. Stars formed. Galaxies assembled. Small systems merged into larger ones. The cosmic web grew. Voids emptied. Clusters became massive. Across billions of years, the universe organized itself, and the distance between galaxies today carries traces of that ancient process. Where galaxies are found, where clusters form, where voids open, how galaxies move, all of it tells us something about the early universe. In this way, galactic distance is not just space between objects. It is fossil structure. The large-scale arrangement of galaxies is a remnant of cosmic beginnings, a pattern grown from the earliest differences in density. When we map galaxies, we are mapping the memory of the young universe. We are seeing how small, ancient variations became the vast architecture of today. This idea is almost impossible to hold fully. The distribution of galaxies across billions of light years is connected to events that happened when the universe was young. The largest structures we see now began as tiny differences, almost nothing, subtle unevenness, and gravity turned those differences into the cosmic web. That means the distance between galaxies is part of the universe's biography. It tells us how matter gathered, how emptiness grew, how light formed islands, how darkness became structure. This is why the galaxies are not simply scattered. They are arranged by history. Every cluster has a past. Every void has a past. Every filament has a past. And Earth sits inside the result of that ancient unfolding. We are not outside the story. We are inside it. The atoms in our bodies formed in stars inside galaxies. The Sun formed in the Milky Way. Earth formed from material enriched by earlier generations of stars. Life emerged on a planet inside one galaxy. And now that life looks outward and studies other galaxies, there is something deeply circular about that. Matter organized itself into stars. Stars created elements. Elements formed planets. One planet produced minds. Those minds built telescopes. And those telescopes look back across the universe to understand the galaxies that made such minds possible. The distance between galaxies is enormous, but consciousness crosses it in its own way. Not physically, not with engines, but through attention. A photon leaves a galaxy, travels for millions or billions of years, enters a telescope, becomes data, becomes an image, becomes a thought in a human mind. That thought did not exist when the photon began its journey. The galaxy sent light into a universe without knowing it would one day be received by a species on a small planet. And yet, it was. This may be one of the quiet miracles of existence. Not supernatural, not magical, but real, ancient light becoming modern understanding. A galaxy beyond reach becoming part of human thought. Distance does not prevent meaning. It changes the form of meaning. We may never stand inside most galaxies. We may never cross the void. We may never speak to any life that might exist there, but their light still changes us. It expands the boundary of what we believe reality is. It makes Earth smaller. It makes time deeper. It makes our problems feel both fragile and precious. It teaches scale. And scale is not only scientific, it is emotional. To understand the distance between galaxies is to feel a kind of emotional stretching. The mind tries to reach outward, from the room to the city, to the planet, to the solar system, to the Milky Way, to Andromeda, to clusters, to the cosmic web, to the observable universe. Each step makes the previous world smaller. But not worthless. This is important. Smallness does not erase meaning. Earth is small compared to the Milky Way. The Milky Way is small compared to the cosmic web. Human life is short compared to galactic time. But meaning does not require size. A single thought can contain a galaxy. A brief life can understand ancient light. A small planet can become aware of the universe. That is why cosmic scale is not only frightening, it is also strangely beautiful. Because the universe is vast enough to humble us, and yet we are capable of knowing that we are humbled. Galaxies are distant, but they are not meaningless to us. Their distance gives us perspective. Their light gives us history. Their number gives us wonder. Their separation gives us a sense of the universe's depth. And their future reminds us that nothing is fixed forever. Even galaxies change. Even cosmic islands evolve. Even the Milky Way will not always be the Milky Way. Andromeda is coming, slowly, quietly, across the dark. One day, the two galaxies will begin their long gravitational encounter. The night sky would become unrecognizable. New star formation may ignite in vast clouds of gas. The structure of the galaxies would stretch and twist. Over immense time, the two would settle into a larger system. And if some future intelligence survives inside that merged galaxy, it may inherit a new sky, a sky built from the ruins of two ancient spirals, a sky where the sun, if it still exists in some remnant form, is only one star among an even larger structure. But there is another layer. By the time the Milky Way and Andromeda merge, the universe beyond the local group will be more distant. Many galaxies now visible may be farther, fainter, more redshifted. The local future may become gravitationally richer, while the distant universe becomes observationally poorer. A merged local galaxy surrounded by increasing cosmic darkness. That is the future. A great island formed from nearby galaxies, while the far islands drift out of view. This is one of the most poetic and unsettling images in cosmology. The local galaxies come together. The distant galaxies disappear. Gravity gathers what is close. Expansion carries away what is far. The universe becomes both more united locally and more isolated globally. This is not something humans will watch in any ordinary way, but understanding it changes how we see the present. Right now, we live before that isolation is complete, before the far universe fades, before our galaxy merges with its neighbor, before the cosmic web becomes hidden from future observers. We live during a visible chapter, a chapter rich with evidence, a chapter where the distance between galaxies can still be studied across enormous ranges. And maybe one of humanity's tasks is to notice that, to look, to record, to understand as much as we can while the universe still offers its light, because the universe will not always look this way. That is something people often forget. We imagine the night sky as eternal, but the sky has changed. It will change. Stars move, galaxies evolve. The expansion continues. The cosmic view belongs to an era. We are living inside one version of the universe. Not the first, not the last, and perhaps not the easiest to understand, but a remarkable one. A universe old enough to have galaxies, planets, chemistry, and life, but young enough that distant galaxies are still visible, old enough for consciousness to emerge, young enough for the cosmic story to be readable. This balance is extraordinary. If we had appeared much earlier, there may have been no planets like Earth. If we appeared far later, much of the evidence of the wider universe might be gone. But now, in this window, we can see. And what we see is overwhelming. Galaxies beyond galaxies. Clusters beyond clusters. Ancient light from deep time. Structures larger than imagination. And distances that tell us the universe is not made for our convenience. The distance between galaxies may be worse than we think, but that difficulty is part of its power. If galaxies were close and easy, they would not teach the same lesson. If the universe were small, it would not expand the mind in the same way. If every destination were reachable, mystery would shrink. But because most galaxies are beyond reach, they remain both real and transcendent, not supernatural, but beyond touch. They force us to separate knowledge from possession, to understand without owning, to admire without arriving, to accept that reality contains things we may never stand beside. This is a hard lesson, for a species built to explore physically. Humans like footprints. We like arrival. We like flags, maps, paths, borders, journeys. But astronomy teaches another kind of relationship. Some places can only be known through light. Some histories can only be reconstructed. Some distances can only be respected. Some mysteries may never become destinations, and yet they still matter. Andromeda matters, even if no human reaches it. Distant galaxies matter, even if their presence is unknowable. The cosmic web matters, even if no ship can cross its filaments. The observable universe matters, even if most of it will remain physically inaccessible. Knowledge is not less valuable because it is remote. Sometimes distance makes knowledge more precious. A galaxy's light may travel millions of years to reach us. When we detect it, we are receiving something fragile, a signal that survived darkness, a message from an ancient structure, a piece of reality arriving from beyond human scale. That should feel special, not routine, not just another image. Every galaxy image is a meeting across time, a silent contact between Earth and the deep universe. No words, no intention, only light. And that light tells us that we are part of something vast, not central, not separate, part of it. The atoms in our bodies belong to the same cosmic story as the stars in those galaxies. The physics that shapes Andromeda shapes us. The gravity that pulls galaxies together also holds Earth in orbit around the Sun. The elements created in stars became planets, oceans, bones, and brains. The universe is not something outside us only. It is the larger system of which we are a temporary expression. This may be the most calming side of cosmic distance. Yes, galaxies are far. Yes, the voids are immense. Yes, most of the universe may remain unreachable, but we are not outside the universe looking in. We are inside it, made from it, able to know it. That connection does not erase the distance, but it gives the distance meaning. The galaxies are far away, but not unrelated. They are different branches of the same cosmic history, other outcomes of the same beginning, other structures formed under the same laws, other islands of stars in the same expanding sea. And when we observe them, we are the universe becoming aware of its own scale, a small part of the cosmos looking back at the larger whole. That is why the distance between galaxies is not only terrifying, it is sacred in a quiet scientific sense. It shows us that reality is deeper than survival, larger than daily life, older than memory, wider than imagination, and still, somehow, visible from a small world. A person can stand under the night sky, see almost nothing with the naked eye, and still be surrounded by galaxies in every direction. The darkness is not empty. It is layered with ancient light, some of it too faint to see, some of it stretched beyond visible colors, some of it waiting for instruments strong enough to capture it. But it is there. The universe is full of galaxies, full of distances, full of histories, and we are learning to read them. Part 5 brings the story into this future and this meaning. The future where galaxies merge. The future, where distant galaxies fade. The present, where their light still reaches us. The strange era, where humanity can record a universe that will not always be visible in the same way. And the deeper realization that distance does not only separate, it reveals. It reveals time. It reveals structure. It reveals history. It reveals our limits. It reveals our place. A galaxy millions of light years away is not only a far object, it is a teacher. It teaches patience, because its light took longer than human history to arrive. It teaches humility, because it contains more stars than we can easily imagine. It teaches uncertainty, because we do not see its present. It teaches beauty, because even across impossible distance, it still shines. And perhaps that is why galaxies remain so emotionally powerful. They are unreachable, but visible, ancient, but present in our sky, separate, but connected by light, silent, but full of information, distant, but capable of changing the way we understand ourselves. When you look at a galaxy, you are looking at something that may never be touched by human hands. But your mind can still reach it, not completely, not perfectly, but enough. Enough to know that it exists. Enough to know that the universe is larger than the Milky Way. Enough to know that our galaxy is one island among countless others. Enough to know that the darkness between those islands is not empty of meaning. It is filled with scale. And scale is one of the deepest truths the universe gives us. So maybe the distance between galaxies is worse than we think, because it defeats our instinct for closeness. It shows us a universe where most things are not nearby, where most destinations are not destinations for us, where the present of distant worlds is hidden, where expansion slowly removes parts of the cosmic map. But it is also greater than we think, because it turns the sky into history. It makes every telescope a time machine. It allows ancient galaxies to speak through light. It gives us the chance to witness the universe not only as a place, but as a story. And that story is still unfolding. In the end, the distance between galaxies does something strange to the human mind. At first, it feels like a number, a measurement, a scientific fact. 2.5 million light years to Andromeda, hundreds of millions of light years to distant clusters, billions of light years to the oldest galaxies we can see. But after a while, the numbers stop behaving like numbers. They become something deeper. They become a feeling, a quiet pressure, a sense that reality is far larger than anything human life was built to contain. Because we are creatures of closeness, we understand distance through walking, through roads, through maps, through travel, through the time it takes to move from one place to another. A room feels close, a city feels larger, a country feels huge, a planet feels almost beyond daily experience. Then, astronomy takes that human sense of scale and stretches it until it almost breaks. The moon becomes far. Mars becomes farther. The nearest star becomes almost unreachable. Then galaxies appear, and suddenly, even the nearest star feels close compared to the darkness beyond the Milky Way. That is what galaxies do. They reset the scale. They remind us that our entire solar system, with all its planets, moons, asteroids, comets, spacecraft and dreams is only a tiny detail inside one galaxy. And that galaxy itself is only one island among countless others. From Earth, the Milky Way is home. It is the great structure that holds the sun. It is the region where every human life has unfolded. Every sound, every memory, every ocean, every mountain, every civilization, every night sky ever seen by human eyes, all of it has existed inside the Milky Way. And yet, from far enough away, our galaxy would not look personal. It would look like a spiral of light, beautiful, distant, silent, a glowing shape in a much larger dark. Earth would not be visible. The sun would be lost among hundreds of billions of stars. Human history would leave no obvious mark. All our wars, discoveries, languages, songs, cities, fears, hopes, and questions would be hidden inside one small point of light. That thought can feel frightening, but it can also be strangely peaceful, because the universe does not diminish us by being large. It simply shows us where we are. It shows us that we are not the center of everything, not the measure of everything, not the reason galaxies shine, but we are part of the same reality. The same universe that built galaxies also built the atoms in our bodies. The same gravity that gathers stars into islands of light also holds Earth near the sun. The same ancient processes that shaped distant galaxies eventually made planets, chemistry, oceans, and life possible here. So, when we look at galaxies, we are not looking at something completely separate from us. We are looking at other expressions of the same cosmic story. Different islands, different histories, different arrangements of stars and dust, but all born from the same universe. And maybe that is why the distance between galaxies feels so powerful, because it separates and connects at the same time. It separates us physically. It places most galaxies far beyond any journey humans can imagine. It makes conversation across those distances almost impossible. It hides their present from us. It turns their light into history. But it also connects us through observation, through physics, through ancient light, through the simple fact that a photon can leave a galaxy millions of years ago and end its journey inside a telescope near Earth. A tiny piece of another galaxy can become part of human understanding. That is not travel in the ordinary sense, but it is still a form of contact. Silent contact. A galaxy does not speak to us with words. It does not know we are watching. It does not send a message with intention, but its light carries information. Its shape tells us about gravity. Its color tells us about stars. Its motion tells us about expansion. Its distortions tell us about dark matter. Its distance tells us about time. And from that light, humans build meaning. That may be one of the most beautiful things our species does. We take faint signals from the dark and turn them into knowledge. A galaxy that no human will ever touch becomes part of our story. Not because we conquer it, not because we reach it, but because we understand a little more of what it is. This is where the distance between galaxies becomes more than terrifying. It becomes humbling in the deepest way. It teaches us that not everything real is reachable. Not everything meaningful can be touched. Not every destination must become a place for footprints. Some parts of the universe may only ever be known from far away, through light, through patience, through careful instruments, through imagination guided by evidence. And maybe that is enough. Not always emotionally, because humans want to go. We want to cross. We want to stand somewhere and say, "We arrived." That instinct is ancient. It pushed people beyond familiar valleys, across oceans, into the sky, toward the moon. It may one day push us to Mars, to the moons of Jupiter, to the outer solar system, and perhaps even to nearby stars. But galaxies ask for another kind of humility. They ask whether knowing can matter, even when reaching is impossible. They ask whether wonder can survive without a rival. They ask whether we can love a universe that may never become accessible to us. And the answer, somehow, is yes. Because galaxies have already changed us. Long before anyone could dream of traveling between them, they changed our idea of reality. There was a time when humanity did not know other galaxies existed. The Milky Way seemed like the whole great starry structure. Those faint, cloudy objects in telescopes were mysterious. Some thought they were nebulae inside our own galaxy. Then, slowly, through observation and measurement, the truth became clear. The Milky Way was not the entire universe. Those faint spirals were galaxies of their own. Other islands of stars, other systems as vast as ours. That discovery was one of the greatest expansions of human perspective. The universe did not become physically larger in that moment. It was already large, but the human universe became larger. Our understanding grew. The walls moved outward, and since then, every deeper look has done the same thing again. More galaxies, farther galaxies, older galaxies, galaxies from a younger universe, galaxies distorted by gravity, galaxies forming stars, galaxies whose light began traveling before Earth had complex life. The more we look, the more the universe refuses to be small. And this is why the night sky is misleading. To the naked eye, it looks quiet. A few thousand visible stars under dark conditions. A pale Milky Way band, if the sky is clear enough. A few planets. Maybe Andromeda as a faint smudge. It seems almost manageable. Beautiful, yes. Vast, yes. But not overwhelming in the way modern astronomy reveals. Because the human eye only sees the surface. The sky hides its depth. Behind the visible stars are galaxies. Behind the bright galaxies are fainter galaxies. Behind the fainter galaxies are ancient galaxies. Behind what we can see are regions whose light may never reach us. The darkness is not empty. It is layered. It is filled with distance, and distance is what makes the universe feel quiet. If galaxies were closer, the sky would be different. If the Milky Way were inside a dense cluster, our night might contain many more visible galactic neighbors. If Earth existed deep inside a cosmic void, the sky might feel much emptier. Our view of the universe is shaped by where and when we exist. This matters because we often imagine the universe as though our view is the natural one. But every observer sees from a position. Every civilization, if others exist, would inherit its own cosmic sky. Some may see abundance, some may see isolation, some may live under skies filled with nearby galaxies. Others may live in lonely regions where the nearest great galactic structures are faint and distant. The universe is the same universe, but the experience of it changes depending on the island where life awakens. For us, the Milky Way is our island, and Andromeda is the nearest great reminder that we are not alone in the larger cosmic sense. It is coming toward us slowly. One day, far beyond our time, the Milky Way and Andromeda will merge. The night sky of that future will not resemble ours. A huge galaxy will grow across the heavens. Stars will move into new orbits. Gas will be stirred. The old spiral identities will fade into a new structure. And some future intelligence, if it exists, may live in a galaxy made from both. They may look back through records and learn that once there were two great spirals, the Milky Way, Andromeda, separated by millions of light years, then bound together by gravity, then merged by time. To us, that future feels almost unreal, but to the universe, it is simply another chapter. Galaxies are not fixed monuments. They are processes. They evolve, they collide, they merge, they grow, they fade. They carry the history of everything that shaped them. Even our own galaxy is not permanent in its current form. The Milky Way we know is temporary, long-lived, yes, ancient by human standards, but temporary. That is another lesson galaxies teach. Even the largest structures change. Not quickly, not in human rhythm, but they change. And this changes how we should think about distance. The space between galaxies is not frozen. It is part of a moving universe. Some galaxies approach, others recede. Some are bound by gravity, others are carried away by cosmic expansion. Some will merge, others will disappear beyond the horizon of observation. The universe is not a still map. It is a changing story, a story written too slowly for our eyes, but not too slowly for science. And perhaps this is why astronomy feels so powerful. It allows short-lived beings to understand slow processes. We cannot watch galaxies merge in real time, but we can observe galaxies at different stages. We can simulate their future. We can see distorted systems. We can study ancient light. We can build a story from evidence scattered across space and time. In that sense, the human mind does something extraordinary. It compresses cosmic time into understanding. It takes events lasting billions of years and holds them as ideas. It turns distances too vast to cross into thoughts that can be spoken. That is not small. A human being may be physically tiny, but understanding is not measured in kilometers. A mind can hold Andromeda. A mind can imagine the local group. A mind can picture the cosmic web. A mind can understand that the light from a galaxy may be older than the species looking at it. That ability is one of the rarest things we know, and maybe it gives our smallness a different meaning. We are not large. We are not long-lived. We are not powerful compared to galaxies. But we are aware. For a brief time, matter in the universe has arranged itself into minds capable of asking what galaxies are. That may be enough to make our moment precious, because the universe does not need us to observe it. Galaxies would shine without us. Clusters would form without us. Voids would expand without us. The Milky Way and Andromeda would still meet one day. Distant galaxies would still drift beyond reach. Light would still travel. But because we exist, some of that light becomes known. Some of that distance becomes felt. Some of that silence becomes part of a story. And perhaps that is what a space documentary is really doing. Not simply explaining facts, but helping the mind feel the scale of existence, helping the listener move gently outward from Earth to the solar system, to the stars, to the Milky Way, to Andromeda, to clusters, to the cosmic web, to the edge of what can be seen, and then, quietly, back to Earth, because every journey outward changes the return. After thinking about galaxies, Earth does not become less important. It becomes more fragile, more specific, more miraculous. A small world inside a galaxy. A place where life emerged. A place where consciousness opened its eyes. A place where beings made of star-formed elements began studying the stars themselves. This is why cosmic distance can create gratitude. The universe is vast, yes, almost unbearably vast. But here, in one small corner, something is alive enough to notice it. That does not solve the loneliness of the cosmos. It does not make galaxies closer. It does not turn the void into a road. But it gives meaning to the act of looking. And looking may be the first and most honest form of connection we have. Maybe one day, humanity will travel far beyond Earth. Maybe we will build permanent homes on other worlds. Maybe machines will visit nearby stars. Maybe descendants of Earth will spread through parts of the Milky Way. But even if that happens, the distance between galaxies will remain almost sacred in scale. It will still mark a boundary between what a civilization can dream of and what it can realistically reach. And maybe that boundary is important, not because it defeats us, but because it reminds us that the universe is not here to be mastered. It is here to be understood, respected, and wondered at. The galaxies do not ask us to conquer them. They simply shine. Across distances we can barely imagine. Across time we can barely hold. Across darkness that would swallow every human road ever built. And still, their light arrives. A silent gift. A faint trace. A piece of the universe crossing the void until it reaches a small planet. When that light arrives, we may turn it into data, into images, into measurements, into stories, into quiet thoughts before sleep. And through those thoughts, the distance becomes part of us, not physically, but emotionally, intellectually, spiritually, in the broadest sense. We become aware of a universe too large to reach, and that awareness changes how we feel about being alive. This is the final truth of the distance between galaxies. It is worse than we think, because it is not only large, it is layered with time, with expansion, with unreachable presence, with possible histories we will never share, with light that began traveling before human memory, with places that may never become destinations, with cosmic islands separated by silence so vast that even imagination has to move slowly. But it is also more beautiful than we think, because distance gives the universe depth. It turns the sky into history. It turns light into memory. It turns observation into a kind of time travel. It turns small beings into witnesses of enormous things. If galaxies were close, perhaps they would feel ordinary. If the universe were easy to cross, perhaps it would lose some of its mystery. But because the galaxies are far, because the voids are deep, because the light is ancient, every glimpse becomes meaningful. Every image of Andromeda carries millions of years. Every deep field holds thousands of histories. Every faint red galaxy from the early universe reminds us that time itself is visible, and every black patch of sky may contain more than the eye can bear. So when you look into the night, try to remember what is hidden behind the darkness. Not emptiness, not silence alone, but distance. Galaxies beyond galaxies. Islands of stars separated by oceans of time. Some moving toward us, most moving away. Some bright enough to see, others fading beyond reach. All of them part of a universe whose scale is greater than human ambition, but not greater than human wonder. And maybe that is where we should end. Not with fear, not with the feeling that we are nothing, but with the quiet realization that we are small observers inside a vast, ancient, expanding reality. We may never cross the distances between galaxies. We may never stand under the sky of Andromeda. We may never send a message and hear an answer from a civilization in another cosmic island. But we can know the galaxies are there. We can see their light. We can understand a little of their motion. We can feel the weight of their distance. And we can let that knowledge make us gentler with our own world. Because Earth is not ordinary just because the universe is large. It is rare to us. It is home, a tiny blue world inside one galaxy, looking outward at all the others, a shore beneath an endless dark ocean. And from this shore, humanity has begun to listen, to measure, to imagine, to wonder. That may be our first true role in the cosmos, not conquerors, not owners, not masters of distance, but witnesses. Witnesses to galaxies whose light crossed millions of years to reach us. Witnesses to a universe that is both unreachable and knowable. Witnesses to a darkness that is not empty, but filled with ancient islands of stars. So tonight, as the mind drifts toward rest, hold this thought gently. Above us, beyond the stars we can see, beyond the Milky Way itself, there are galaxies scattered across distances almost beyond meaning. They are far, they are old, they are silent, and yet, somehow, their light is here, touching our telescopes, entering our thoughts, reminding us that the universe is larger than fear, larger than certainty, larger than anything one life can fully understand. The distance between galaxies is worse than we think, but the fact that we can think about it at all may be one of the most beautiful things in the universe.